Hey guys, my name is Marcus Casey, and I'm going to be going over my project for this semester, which is gauging United Federal Credit Union's mobile application security. So just going over the applications used here, uh, to the left are the packages that I used for the majority of the testing. These were all installed through Sadea. But on the right, I want to highlight those a little bit more. Those are the applications I actually installed on my MacBook in order to do some high-level testing. iExplore and iAmazing were used to file Explorer and access root on my iPhone in order to grab a lot of the stuff that we used for testing. The Burp Suite is what we use for network testing. We learned about that in class. Hopper and IDA are how I was planning on reversing my binary files to an IPA. I had both of them just in case one of them didn't work. DB browser for SQLite is how I explored the database files on the iPhone, and appetize.io is how I loaded the application in an emulator to do some testing on the emulator. So first off, I started by downloading the app on a iPhone. So this was an iPhone app test, and my iPhone that I used was an iPhone 6 Plus. I downgraded to iOS 12.4.6, which was the latest available version to jailbreak, and I jailbroke that using Jekarn's macOS engine. Checkarn is basically a free open source tool where you just download it to your Mac, you plug in your phone, and 5 minutes later you got a jailbroken phone with Sadea on it, which will allow you to install basically any package. It's a very easy process to jailbreak your iPhone. I did learn that if you jailbreak it, if you restart the iPhone, you have to re-jailbreak it every time, so just FYI. I wanted to use Electro, which is a different version basically of Checkarn, but it's out of date, and that will come back to haunt us later on getting a working IPA file. So let's go over the network analysis key findings. All the network analysis was performed using Burp, which we learned about in class. It's a very simple Wireshark kind of pseudo program which will allow you to capture the traffic on your phone. I set that up by setting my MacBook as a server, establishing a proxy, and then Burp lets you go onto the web browser and install some certificates. Basically, all the network traffic was visible from the start, so I was able to capture everything that the iPhone was doing, including on the application. All the traffic on the app was TLS HTTPS, so that was a plus. Passwords were not hard encrypted on network transmission. That's the very first thing that I noticed is my passwords were being stored raw in the API calls, which I wish that they were able to mask that somehow, but granted, since this is HTTPS and you have to go through all these steps to capture the traffic, probably not a big deal, but still nonetheless thought I'd point that out. And the auth token along with cookies were easily accessible. You could point them out pretty easily. So on to platform results, the key findings. Only search and Siri permissions were requested, very conservative, nothing extra was added. Custom URL handling was fair. I say fair because it was somewhat ambiguous, but also somewhat derivable. Some of the API calls, such as pre-logon user or logon user, were immediately obvious what was going on. You know, it is passing some data for the user to log in with their unique session ID. But there were some API calls, such as in the bottom right-hand corner, such as /united blah 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 /ux.aspx, passing some metadata and getting some metadata. So that was obscured. I think that they could change the pre-logon user and logon user stuff to be a little bit less obvious since this isn't an open API. I wasn't able to hijack universal URLs. I tried to by putting them into the Notes app on the phone to try to see if I could get other apps to interact with that app, but Apple's pretty good about that, and it looks like that the United developers were good at making sure that wasn't possible as well. Moving on to authentication and session management, there was basically pretty standard results throughout the board. No interaction unless a username or password is entered. You couldn't just force your way into the application doing some random combination of inputted devices. If you wanted to change your password, you had to be on a trusted device. Standard password and two-factor authentication requirements. An access code is required. But what I did highlight a little bit here is initially the session management was pretty suspect. I noticed that my session IDs were the same every time I was logging in, and maybe I was misinterpreting what was going on there, and in my full write-up I go into that. But I was able to get the same session ID passed every single time, even after I reset my phone. I logged off. The cookies were the same. The auto-generated text was the same. I wonder if they do session IDs based on a server timer, based on your user ID, something like that. So cookies also never expired. I never was forced to log out, even though cookies had session timers on them, they never seemed to actually take effect. Like, for example, on my Bank of America app, if I don't touch it for like 15 seconds, it tries to log me out. Never had that problem here. I tried for an hour. I left it open for an hour without locking the screen, making sure the cookie didn't refresh, and it didn't log me out at all. Another thing I noticed that was kind of funny is that there's a pre-generated access code on the API call when it's trying to grab the access code. I thought this was kind of dumb because it immediately tells someone who could be malicious how long the access code should be, what type of symbols can be in the access code. They should probably remove this from their API call, just make it 00000 or just even wrong numbers so that you're not inputting it in order to make sure that someone who's malicious can't immediately figure out what's going on with the access codes. Architecture, design, and threat modeling, pretty quick. I tried to perform some SQL injection. I tried to break a lot of dynamic SQL. I tried a bunch of different things, but also spread throughout the day and weeks because I did not want to flag myself as actually attempting SQL injection, which I guess I was. Since this is a banking application, you'd think that one of their top priorities on designing their databases and their SQL entry points is making sure that you can't perform SQL injection. So this was pretty low percentage chance to work out just from the get-go. One thing of note is that the app did not force version updates, nor did it notify me if I was using an out-of-date app. And for a banking application, you'd think that'd be a top priority since they might be patching loopholes or figuring something out there. So that definitely was a weak showing on that aspect. Data storage and privacy was pretty standard. The keychain did not store login information. The dynamic text file, which is how Apple stores the keyboard cache, did not store personal information or logins. Passwords are masked on the UI side, and the device access security policies average at best. You can add trusted devices, but you can't remove them. You can't block certain devices. They definitely could expand on that to make sure that the user has more power in protecting themselves from attackers. But the one I wanted to really highlight here is third-party software is used without user notification. I checked the privacy policy. I checked everywhere. There's this application that is constantly being called in the API. It's called Pendo.io. And Pendo.io, after looking it up, is basically a third-party marketing company that will track user clicks, engagement, track how your customers are interacting with your app. And this is pretty standard, I think, in most apps, but I definitely didn't see any notice of Pendo specifically. I did notice in the privacy policy they talk about how they share your information, but they didn't really talk about how they share your information upon using the app. So I definitely think that I wouldn't call it malicious or suspect, but I definitely would say that they should disclose that they're sending this data to a third-party vendor. Anti-reverse engineering. So the application did not detect that I was using a jailbroken iPhone. I think that's pretty fair. I don't think most applications are able to detect this pretty commonly. I haven't had any interactions with that. Every database which was SQLite that was stored is password protected. I couldn't break into it trying to use Kali Linux's tools, which I was actually kind of happy about. I didn't really want to figure out a way to break into some credit unions databases that they were storing. Random JavaScript of note was stored in the app component library. This was just accessible if I had root access. I was able to access quite a few scripts that had a lot of core functionality in the application, not really for what would be useful for security testing, but just seeing how the actual application loads the JavaScript and grabs the metadata and JSON parses. They definitely should not include that in the app component. That should be masked somehow. I'm not an app developer that is proficient at that, so I can't say how they should fix that, but I definitely would say having 7 giant JavaScript files with a bunch of unobfuscated code is a good idea. It was incredibly difficult to convert their binary on Hopper or IDA. I could not get a working IPA. And again, that kind of circles back to Electra, which I was talking about earlier. Electra definitely would have made this a lot easier being able to get some IPAs, but unfortunately, I wasn't able to have that to work. So I didn't get any working IPAs to completely reverse engineer the source code. I was able to get some source code, but not all of it. All right, so in conclusion, the application is pretty secure. The use of Pendo is understandable, but should have been broadcasted. They should have definitely notified that. It should be in the privacy policy. It should have a user acceptance agreement when you immediately open the app saying, hey, we're sending this to this random company that you've never heard of before. Improvements absolutely can be made. I talked about a lot of them during this presentation, and honestly, almost all of them were super easy, cheap wins. Being able to remove trusted devices, hiding some of that JavaScript, maybe making your passwords not be stored in plain text when you're passing through your API calls, pretty easy stuff. So I think that the app's secure, but they definitely have some cheap wins where they could improve really significantly and pass a lot of these things that they failed. My chart's on the right. Please let me know if you have any questions, and thanks for listening.